Howdy folks, Mr. K here with an online video about ions. Now, as we've talked about solutions, you may have noticed us write stuff down like this, Na plus or Cl minus, when we're talking about salt ions. These are ions right here. There's a difference between sodium with a positive sign and sodium with nothing. There's a difference between chlorine with a minus sign and a chlorine with nothing. These are atoms. These are ions. Now, let's talk about what the deal is with ions, what exactly they are. They're still atoms, but there's something different about them. So, when we look at the periodic table, we notice something. So, we already said that group 1A, those are the alkali metals, and they are very reactive. We said that group 7A over here, these are the halogens, and they are also reactive. But then we get to group 8A and we get to the noble gases, and they are unreactive. Notice, so there's something about having 8 or in some cases 2 valence electrons that makes you very unreactive. Only 1 valence electron will make you very reactive. 7 will also make you very reactive. But 8, just adding that 8th, or sometimes in the case of helium, 1 more valence electron, suddenly you become a very unreactive substance. It has to do with stability. So, stability is the key to understanding elements and ions, because elements and ions, they want to be stable. Things that are reactive, the alkali metals, the halogens, they're unstable. They want to get rid or gain some electrons so they can all be stable and unreactive like the noble gases. Everybody wants to be like the cool kids. The noble gases are the cool kids. All elements want to gain or lose their electrons to be those cool kids. So, stability comes from the highest energy level being complete, meaning either having 8 valence electrons, or in the case of helium, 2. That makes you stable. The highest occupied energy level. Now, there's 2 ways you can go about becoming stable. You can either give them away, or you can take them in, talking about electrons. So in the case of sodium, sodium is in group 1A and it has 11 electrons in its atom form, because remember it's atomic number 11, so in its atomic form it has 11 electrons. When we put those in the energy levels, we find it has 2 in its first, 8 in its second, and only 1 in its third. But remember, this third one could hold 8. It wants 8. It has a full one already in level 2. So it would very much like to get rid of this 1 electron so it can have a nice full stable level 2. Chlorine, on the other hand, has 17 electrons. It has 2 in its first level, it has 8 in its second, and it has 7 of the 8 possible in its third. So it would very much like to gain 1 more electron to become more stable, have a full level 3. It's much easier for sodium to get rid of 1 electron to drop down an energy level, and it's much easier for chlorine to gain an electron. So, when they bond and they form ions, such as sodium chloride table salt, sodium will give away its 1 electron in level 3, making its level 2 its highest occupied stable level. Chlorine will take that electron, because remember, chlorine wants to get 1 more. It will take that electron, giving it a very stable level 3. Now, once again, when sodium reacts with chlorine, it gives 1 of its electrons to chlorine. So now sodium has its level 2 completely filled, but we don't show that. We just show it with a plus sign. And chlorine has its level 3 completely filled. They're happy and they're stable. They have electron configurations like that of the noble gases. But since they've lost and gained their electrons, they're no longer atoms. They're ions. They're things that have a positive or negative electric charge, which is caused by this gaining or loss of an electron. So we showed the little plus signs and minus signs to let us know how many electrons have been gained or lost for that ion. Now, the general rule is that all metals, that's everything to the left of the stairs, will always give away their electrons. That's why metals are good conductors, because they easily pass their electrons. And since they're giving them away, they become positive ions called cations. Remember, cation has a T in it, like a plus sign. Positive is also a plus sign. Remember, a positive ion is a cation. Nonmetals, they always take electrons. Everything to the right of the staircase will take away electrons. Chlorine, sulfur, oxygen. And since they're taking away and gaining electrons, they always form negative ions called anions. Remember, anion has an N in it, just like the word negative. Cation has a T because it's positive. Anion has an N because it's negative. So, this is where those numbers, those positive and negative ones, are coming from. So let's look at regular sodium. Regular sodium is atomic number 11, meaning it has 11 protons, and protons are positive, so it has a plus 11 charge. It has 12 neutrons, which have no charge, they're just there, and the atom sodium would have 11 electrons to match its number of protons. But remember, it really wants to give away 1 electron so it can have a total of 10, like its nearest noble gas. So what sodium does when it becomes an ion, Na+, it still has its 11 protons, still 12 neutrons, but it gave 1 away, so now it only has 10 electrons. It has minus 10 charge. To get charge, you take how many protons you have, so the plus 11, and then add it to your charge number of electrons, minus 10. Positive 11 plus negative 10 is positive 1. So sodium has a charge of plus 1. Let's look at chlorine. Chlorine is atomic number 17. So it has 17 protons, so it has a plus 17 charge. It has 18 neutrons, and in its atom form, 17 electrons. So as it is right now, as an atom, it has no charge on it, because its protons and electrons are equal. But remember, chlorine really wants to get an extra electron. It wants to get 1 more electron. So it gains 1 electron. So after it gains an electron, it still has that positive 17 from its protons. It still has 18 neutrons, but it gained 1 electron, so now it has a minus 18 charge for its electrons. So its charge would be a positive 17 plus a negative 18 gives us a negative 1 charge. Let's practice figuring out what, based on an element, where it is, what its ion charge would be, how many electrons the ion would have, whether it gave or took electrons, and how many electrons it gave or took. So, hydrogen. Hydrogen is in group 1A. It has 1 valence electron. Even though hydrogen we consider it a nonmetal, it's to the left of the staircase. And it says right here that group 1A metals, or hydrogens included, will have a charge of plus 1. Everything in group 1A is plus 1, so hydrogen's charge will be plus 1. That means its total number of electrons, remember hydrogen normally has 1 electron, but it gave it away. If it's positive ion, it gave it away. So now it has no electrons because it gave, or it's giving electrons. How many electrons did it give? 1. It gave away 1 electron. Bromine. Bromine is in group 7A. It's a halogen. It says right here that 7A elements have a charge of minus 1. So, bromine is normally atomic number. Bromine Bromine is normally atomic number 35. So usually it would have 35 electrons, but it formed a negative ion. It has a charge of -1 in its ion, meaning it will take in 1 electron. So it has in its ion 36 electrons. Just like krypton, its nearest noble gas. So it is taking electrons, and it took in 1 electron. Oxygen. Oxygen has a charge, or it's in group 6A. So its ion charge will be -2. Normally, oxygen is atomic number 8, so it would have 8 electrons. But it's got a -2 ion charge, and minus means it took in electrons, so it now has 10 electrons, just like its nearest noble gas, neon. So oxygen's taking electrons, and it's taking 2 of them. You will have this worksheet in class. I expect it done for the notebook check. If you have any questions, come see me, and that's everything about ions. I will see you in class.